We now discuss the solution of a problem from the section Coordinate Geometry, and the problem is on the eccentricity of an ellipse. This problem appeared in JEE Main examination held on 22nd July 2021 in the afternoon shift. The problem is, let E1, whose equation is x square by a square plus y square by b square is equal to 1, where a greater than b. Let E2 be another ellipse such that it touches the endpoints of the major axis of E1 and the foci of E2 are the endpoints of the minor axis of E1. If E1 and E2 have the same eccentricities, then its value is given by. The four options are given. So we have to find the value of the eccentricity. We now discuss the solution of the problem. The given ellipse is E1, whose equation is x square by a square plus y square by b square is equal to 1, where a greater than b. So these are the endpoints of the major axis and these are the endpoints of the minor axis. And we have E2, which is passing through the endpoints of the major axis of E1. So E2 is x square by a square plus y square by c square is equal to 1. If you put y is equal to 0, you will get x square by a square is equal to 1. X is equal to plus r minus a. So this ellipse E2 passes through the endpoints of the major axis of the earlier ellipse E1. And it is c greater than a. E2 is here, and we compute the eccentricity of the first ellipse. E1 is equal to under the square root of 1 minus b square by a square. So the semi-minor axis square by semi-major axis square. And similarly, in the case of E2 is E2 is equal to under the square root of 1 minus a square, that is the square of the semi-minor axis of E2 by the square of the semi-major axis of E2. And it is given E1 is equal to E2, and let us call that as E, say. Then both are equal. Under the square root of 1 minus b square by a square is equal to under the square root of 1 minus a square by c square, squaring on both sides and cancelling 1 and changing the sign, we get b square by a square is equal to a square by c square. From this we get c square is equal to a power 4 by b square, and we get c is equal to a square by b. We continue in the next slide, and we bring forward c is equal to a square by b. The situation in the diagram is here. The foci of E2 are 0 plus or minus c times E. C is the semi-major axis of E2 multiplied by its eccentricity, and it's on the y-axis, 0 plus or minus c. But it is given in the question, the foci of E2 are the endpoints of the minor axis of E1. So the minor axis of E1, the endpoints are 0 plus or minus b. So this will imply b is equal to CE. and this will imply E is equal to B by C, and B into 1 by C is B by A square, B by A square from here, and that will be B square by A square. Now from 1, E1 is equal to under the square root of 1 minus B square by A square. E1 is nothing but E into under the square root of 1 minus E. Why? Because E is B square by A square. Squaring on both sides, E square is equal to 1 minus E, and thus we get a quadratic in E square plus E minus 1 is equal to 0, and solving we get E is equal to minus 1 plus or minus root 5 by 2. Thus we get E is equal to minus 1 plus root 5 by 2, which is positive, and we take it, and the other value minus 1 minus root 5 by 2 we reject because it is negative. Eccentricity cannot be negative. The options what we have are here, and our answer E is equal to minus 1 plus root 5 by 2 appears against the option 4. So therefore our final answer is option 4. So that is the discussion of the solution of a problem from coordinate geometry, which is on the eccentricity of ellipse. I hope that you have understood the solution of it, and I wish you all the best. Thank you.